Hello guys, welcome to day 2 of scientific method and measurements. Now, yesterday we talked about measurements, specifically 3 base units, which are meter, liter, and grams, each used to measure length, volume, and mass. And today we will learn about the scientific method of experiment. And specifically, we will learn about how measurements are used in the scientific method to conduct various experiments, either in the field of science or in everyday life. So, scientific method is the logical approach that we use to find solutions to problems. It is a systematic way of finding answers, and it is systematic because we have a 6-step process that we go through to find those answers to the questions or to our problems. Now, the very first step is identifying the problem. What would you like to know? So, from yesterday, if you remember, I talked about the case where if I was a human for the very first time and I had stomach pains, right? And now my problem is the stomach pain, and I would like to know what's causing it, right? Now that will lead me to the second step, which is research. Now the research includes looking it up on the internet, talking to people, looking for relevant material in the library, or looking up the textbooks and scientific magazines, etc. Now in my example, when I research, I find out that, oh, there's something called hunger. And if you're a human, if you don't eat, you might have stomach pains, right? So that was my research. Now that will lead me to forming a hypothesis. Now that's step 3. Hypothesis is simply making an educated guess regarding my question, right? And these are normally based on research and life experiences. And the guess should be testable and measurable. That is the most important thing when it comes to forming a hypothesis. In my case, I form an educated guess that, oh, just eating something will make it go away, right? Now, that is my educated guess. Now, that's testable, right? I can try eating and seeing if it goes away, and if it comes back later, I can try something else, right? So that is testable. But if I chose an educated guess like, oh, if ghosts exist, then the pain will go away. Now, there is no way I can test this or measure this. So it is not an accurate hypothesis. We need to make changes in that hypothesis, right? So after you make an educated guess, you go to test that guess, right? That is when we reach step 4, which is designing an experiment. And you design an experiment to test that educated guess or to test the hypotheses. And this is when observations are used to measure data. Now, when we have experiments, we have 3 important variables that we need to learn about. The first one being independent variable. Independent variable is a part of the experiment that we change to see how it affects the dependent variable, right? And it is graphed on the x-axis. X-axis is the horizontal one on the graph. So it is the one that we change, right? For example, if I was conducting an experiment and I wanted to learn how many fries later will I stop being hungry and when will I stop having stomach pains, right? So the thing that I change in this experiment is the number of fries. Now that is the independent variable. On the other hand, the dependent variable is a part of the experiment that changes in response to the independent variable, right? It is graphed on the y-axis. The y-axis is the one which is vertical on the graph. Now, in the same example that we are talking about, the pain, the stomach pain or the hunger that I'm feeling is the thing that changes in response to the number of fries that I eat, right? Which is the independent variable. And finally, we have control variables. Control variables are those that are held constant and used for comparing. Now, let's take an example of the same hunger example, and let's say that I find another friend who also told me was their first day of becoming human and they are also feeling hungry, right? So we both decide to conduct this experiment together. And I say, okay, I learned about this, it's hunger, and I think eating something will make it go away. So let me try and test this hypothesis and make sure I'm right, right? So what I do is I go and eat 10 fries, for example, and I say, oh, okay, so I've eaten 10 fries and I don't feel hungry anymore. But you, on the other hand, the friend does not eat anything to make sure this is what is causing it, right? It's not just something that stays and goes away, right? So they are a control variable. And the next thing that we need to remember is that the larger your sample is, the more accurate your results are. Now, in this case, it's just me and my friend. But if we had more people doing this experiment, the chances are that this result is also more accurate. So it might be necessary to recruit more people or find more people who are also facing the same problem that I am, to making sure that my results are the only reason why this problem exists in the first place. A sample is nothing much but just a group of people that match the characteristics of a given population, right? And results are more accurate when the sample is bigger. Let's take another example. Let's say I want to conduct a test with all the people who have brown eyes. Now, there are a lot of people in this world with brown eyes. Can I test each and every one of them? Of course not, right? So I will only handpick and choose like 10 people from our school. Now, those 10 people are a sample, and the rest of the people in the world is the population for that given characteristic, right? So when I choose the larger number of people from that sample, the chances are I will have more accurate results. And it might be necessary for me to repeat my experiment time and time again to reduce errors and to make sure that my hypothesis is accurate. And finally, we come to results. Now, results is the information that we have gathered as a result of the experiment, right? And this is the result for a study can be quantitative. Quantitative basically means numbered data, which is recorded by charts, tables, graphs, etc. And in the hunger experiment, it would be the number of fries, right? How many number of fries, how much did I eat to make sure the hunger subsided or how the pain went away. So that is the numbered data, and that was a quantitative experiment. And that finally brought us to the sixth step, which is conclusion. And conclusion is nothing but giving a summary of overall results. And we basically state whether we accept or reject the hypotheses. Now, accepting or rejecting the hypotheses basically means that once we have conducted the experiment and we realize, oh, it was actually me being hungry and eating it did make it go away, right? So that's me accepting the hypotheses. But if there was a case where I ate but still felt hungry, that would be not true, right? Because my hypothesis was I am hungry. If I eat, the pain will go away. But even if I ate and it did not went away, I'm rejecting that hypothesis and trying to create a new one, and we basically go the whole cycle time and time again until we find a hypothesis that is accurate. And in the conclusion, we also describe if there are any practical applications to what you've learned, right? So where else can I use this knowledge to make sure as many people can be helped as possible? Now, this is a quick chart that we can use to summarize what we have learned. We ask a question, we do background research, we create a hypothesis, which is an educated guess, then we test it with an experiment, and we see, oh, is it working? If it's working, then we go ahead and analyze data and draw conclusions. And then we see if it is the same as the hypothesis, if the hypothesis came true or not. If it does come true, then we go ahead and communicate results. If it does not come true, we again go back here and construct a new hypothesis. And that is basically all that I had for you today. I will see you guys later and have a great day.